Hi everyone. In this lesson we're going to be talking about networks and a thing called a spanning tree, which is a subset of a network. Now first let's just begin by thinking about what a tree would look like if we were back in kindergarten and we were drawing a tree. We'd probably draw something like this. We'd start with a trunk and we'd split it up into branches, and then we'd go into smaller branches, and then eventually we'd say that's enough, and there's our little picture of a tree. Now that does look a little bit like a network. Each of those lines could be edges, and each of the intersections could be vertices. But there's something that you will never see in a tree. You'll never see something like this. You'll never see two branches coming from the same point and then rejoining, at least not in regular normal trees. You'll never see something that goes like this. And you'll never see something where one branch here connects across to a branch over here. As soon as I've added any of those features, it no longer looks like a tree. So this gives us our definition of a tree. We're going to have no loops. We have no cycles. And we have no multiple edges. If we have no loops and we have no cycles and we have no multiple edges, then what we're left with is a tree. And that applies in network diagrams as well. So as soon as I take those features out, that looks like a tree, and that's exactly what we're going to use as our definition of a tree in networks. Let's see an example of this. Determine whether each of these graphs is a tree. Well, let's look at part A. We have multiple edges here between B and C. That is not a tree. Let's look at B. We have all the vertices there, they're connected, that's good. We don't have any multiple edges, we don't have any loops, we don't have any cycles. Yes, this one is a tree. Over here, well, we have cycles, so we could go all the way around the outside. That is not a tree. This one has a loop. D is not a tree. Now here's something that I didn't mention earlier, but trees, obviously, all the parts of a tree are connected. So that one is not a tree either. That one could be two separate trees, but it's not a single tree. So there we go. Let's try this. We've been given a network diagram, and they're asking us to draw a tree. That's good. But they say a spanning tree. Now it's just like you might think. A spanning tree is something that spans the entire network, something that includes every vertex. Now we don't have to include every edge, of course. Given this whole network here, well, we can see some cycles, can't we? We have to just highlight the edges we need to include to be a tree. Now, we do this by trial and error. So I've decided here that I'm going to start with vertex H because it looks central, and I will highlight the edges that go off from H to vertices which are each one step away. So we're pretty good. We now have to have some extra connectors, some extra edges to hook in vertex B, E and G. Well, I could go here or I could go here. Either one is fine, as long as, or I could even go here, as long as I don't form a loop. For E, I could use this one, but for clarity I think I'll choose this one. Now for G here, I think I might just go across there. The highlighted arcs are a tree because there are no loops, there are no cycles, and there are no multiple edges. The highlighted arcs include every vertex of the original network. So the ones I have highlighted are a spanning tree. Now it's not the only possible solution, I should say that. It is not. There are other solutions that would also be a spanning tree. Then we name the edges which we do not want to include. So I would suggest we leave out the edge AG, the ones that aren't highlighted, AF, BC, CD, CE, and finally EF. I think that's all of them. I've got 6 there. Let's count them. 1, 2, 3, 4, 5, 6, 7. Oh, I haven't got them all, have I? BI, we didn't write that one down. And what the other one did I miss? Did I go CE? Yes, I did CD. Yes. EF? Yes. I missed AG, didn't I? I didn't have... Oh no, AG is there. AF is there. That's those two. It was AI that I missed. I didn't do that one. So, there's the answer to that question. And I think that's the end of the ideas for a spanning tree. Okay, thanks for watching. See you next time.